Hello everybody, my name is Kiran. I am working as an assistant professor in the Department of EEE Anits. I welcome you all as a part of the course Network Theory. These are the series of lectures on the topic network topology. So the various contents in this video lecture will be: first we are going to see what are the basic terminologies that are going to be used in this network topology. Then secondly, we are going to see the procedure, how to construct an incidence matrix. Thirdly, we are going to see the procedure of how to construct a tie set matrix. And fourthly, we are going to see the procedure of constructing cut set matrix. And using these matrices, how we can write the equilibrium equations, we are going to see lastly. So in today's lecture, we are going to see the various terminologies that we use in network topology, and we are also going to see how to construct an incidence matrix. So first, what is network topology? Network topology is nothing but a graphical representation of an electrical circuit. It is generally used for analyzing very complex circuits by converting them into the network graphs. And in general, we also call this as graph theory. So now let us discuss what are the various basic terminologies that they are going to use in the concept of network topology. First one is node. It is nothing but a common point at which three or more branches meet together. And second one is a branch. It is nothing but any element that can be either inductor or capacitor or any source. So if we take any circuit, the element that is connected between any two nodes, that when I replace by a simple line segment, and each line segment we call it as branch. Next, graph. So when you are given an electrical circuit, every element in that electrical circuit I have to replace by a line segment. That is nothing but we have to replace by a branch. So after replacing an electrical circuit by a geometric figure, as we can say, so whatever geometric figure we obtain, so when we replace all the network elements that are present in the given circuit, that we call it as a graph. So we can define it as a geometric figure obtained when all network elements are replaced by the line segment and the original sources replaced by internal impedances. That is, if you have a voltage source, I should replace by short circuit. Suppose if I have a current source, I need to replace by an open circuit. Then oriented graph or directed graph. So as we have seen, what is a graph? So graph is nothing but a diagram or the figure we have obtained when we replace all elements by line segment. So in that graph, if every branch is assigned some particular direction and all the nodes are numbered, then we call it as an oriented graph. So a graph is said to be oriented or directed when all nodes are numbered and branches have a particular direction. So obviously unoriented graph or undirected graph is nothing but a graph in which the nodes are numbered but the branches that are there, they do not have any particular direction. Okay, so planar graph. Planar graph is nothing but, so suppose if you draw a graph or if I convert a circuit into a graph, so if I draw a graph in such a manner on 2D plane so that no two branches intersect each other. So except at a node, if we do not find any two branches meeting at a common point, then such graph is called planar graph. But if we draw a graph in such a way that apart from node, if any two branches intersect at any point, then that graph is called as non-planar graph. Connected graph. So connected graph means, suppose if I convert a circuit into graph and if I take any two nodes in the obtained graph, Okay, if I find at least one path existing between those two nodes, then we call it as a connected graph. Okay, so suppose if my graph has four nodes, if I consider any two nodes, and between those two nodes at least one path should exist for me to call that graph as a connected graph. If that is not the case, if I don't find at least one path between any two nodes in a graph, then that graph I call it as a unconnected graph. Okay. So that is the basic difference between connected graph and unconnected graph. So in connected graph, at least one path will exist between any two nodes of a graph. But in unconnected graph, then there need not be at least one path between any two nodes of a graph. Yeah. So now whatever basic terminologies we have seen, let us understand by means of an example. So suppose this is the graph, this is the circuit we have. Okay. So how many nodes we have here? So node, I have defined node as a common point in which three or more branches meet, isn't it? So this can be considered as one node because here three branches are there. Remember that this cannot be considered as node because there only two branches meet, and this point also cannot be considered as node because at that only two branches meet. Here I can consider this as a node because here three branches are meet. So here the number of nodes I have two. So the graph, so I have how many elements here? So this I replace by a line segment, this I replace by line segment, this I will replace by line segment. Okay, so once again let me tell you that this is one node and this is one node. Okay, suppose if I take this node as first node and this I consider as second node. Between first node and second node I have 16 ohms resistor. I am replacing 16 ohms. I'm sorry, 1 minute. I am replacing 16 ohms by one line segment, just one line. Okay, between 1 and 2 nodes I also have inductor capacitor in series, isn't it? So here also I will replace, I will replace one line. This also I will replace by another line. So every branch I am replacing by one line segment. Okay, so see here. So this I reference, since it is reference node, I consider as 0. Since this is first node, I consider as 1. Okay, so every branch I have replaced by one line segment. So that is what this graph is. So if you are given a circuit, every element is replaced by a line segment. Okay, and the nodes are numbered. Okay, whatever number is. And if I have any sources, since I have here voltage source, this voltage source I should replace by short circuit. If I have the current source, then I have to replace that by open circuit. Okay, so number of nodes are 2, number of branches are 3. Another example for us to understand. So here how many nodes are there? This is one node, this is second node, and this is third node. Okay, so here I have voltage source. So this is the fourth node. Okay, so 4 nodes I have. So here I have voltage source, I'll replace by a line segment. Here this I'll replace by line segment. This I'll replace by line segment. One more line segment, and this is line segment. So how many branches I got? 1, 2, 3, 4, 5, 6, 7 branches I have. Okay, so graph. So every element I have replaced by one line segment. Okay. So here number of nodes are 4 and number of branches are 6. Okay. So I hope you have understood how we can obtain a graph from the given circuit. Okay. So oriented and unoriented. So I told you before the basic difference between oriented and unoriented. So you can see the clear difference between. So in unoriented, every branch does not have any particular direction. But in oriented graph, every branch will have some particular direction. That is the basic difference between oriented graph and unoriented graph. So next example is planar and non-planar graph. You can see the basic difference. In the first example, I have 5 nodes: 0, 1, 2, 3 and 4. So 5 nodes. So apart from these 5 nodes, no two branches are meeting at a common point. So that we call it as a planar graph. So planar graph is a graph where no two branches meet at a common point other than a node. In the second example, I have 4 nodes: 1, 2, 3 and 4. So apart from these 4 nodes, your two branches of a graph will meet at some common point. So that is the basic difference between planar and non-planar. So non-planar graph is a graph where two branches meet at some common point other than node. Connected and unconnected graph. Okay, so what is the basic difference we can see how many nodes are there in first example? 1, 2, 3, 4. So 4 nodes are there. Take any two nodes. You can see between any two nodes one path exists between any two nodes. But in second example, how many nodes are there? 6 nodes are there. But when I consider second node and fifth node, there is no path between second node and fifth node. When I consider fourth node and sixth node, there is no path existing between fourth node and sixth node. So that is the basic difference between connected graph and unconnected graph. In connected graph, every branch or at least one path exists between any two nodes. But in unconnected graph, that rule does not apply. So at minimum one path also will not exist between any two nodes. Okay. So some more basic terminologies we should know. What is the degree of a node? What is rank of a node? We should understand. So degree of a node indicates the number of branches incident at a node. So how many branches are connected to that particular node? We denote by degree of a node. Rank of a node. If small n is indicating number of nodes, then rank of node can be given by n minus 1. So subgraph. So we know what is subgraph, isn't it? So in maths we would have studied about subset. Okay, the subgraph is similarly. So when I have a graph and I remove some branches from that graph, that will give a subset of the original graph. So a graph obtained by removing some branches and maybe some nodes from the original main graph, we get subgraph. And loop we already know what is a loop. Okay, so a subgraph where each node should have a degree of exactly 2, so that we call it as a loop. Okay, so by example you will understand what are these loop, subgraph and rank. Okay, so in order to understand, I have written here. So here how many nodes are there? 4 nodes are there. How many branches are there? 1, 2, 3, 4, 5 branches are there. Okay, I will consider node 0. Okay, degree is 3 because how many branches are connected to node 0? 3. Similarly, when I consider node 1, 2 branches are there, so degree is 2. Now I will consider node 3. Node 2. How many branches are there? 3 branches, so degree is 3. And lastly, third node, 2 branches are incident, the degree of the node is 2. Okay, so how much will be the rank? So nodes are 4. So rank will be n minus 1, which is 3. Yeah, a tree is nothing but it is a subgraph. That is, it is a part of the original graph where it should contain the nodes of original graph. That means if my original graph has 4 nodes, your tree should also contain those 4 nodes. But no closed loop or no closed path should be present in the tree. Let us try to understand by means of one example in the later slide. So what are the properties of a tree? So it is a subgraph, that is a part of the original graph. It should contain all the nodes of the original graph. Next, third one, it should not contain any closed path. Okay. Fourthly, the rank of the tree should be same as the rank of the original graph. Okay, we can check this later. When we form tree, we can check whether it is um, satisfying all these properties. And the fifth property, there should be only one path existing between any two nodes. Okay, so these are the five properties of a tree. Okay, next, what is twig and link? So these are the three basic terminologies, very important for the entire concept of network topology. You should very well understand what is tree, what is twig, and what is link. Then only we can solve sums based on network topology. Okay, so uh, what is twig? The branches of a tree. So when we form a tree, so that tree, how many branches, whatever branches that tree consists of, every branch is called a twig. Okay, so in order to form that tree, we have to remove some branches from the original graph. Okay, so that branches that we are removing in order to form a tree, we call that as link. Okay, we'll try to understand by means of a simple example. Okay, so if n is the number of nodes and b is the number of branches, this is the formula. Number of twigs will be n minus 1, and number of links will be b minus n plus 1. So this is the given graph. Okay, so here twigs are generally denoted by solid line and links are denoted by the dashed lines. Okay, so this is the original graph. Okay, so for this we need to find the um, tree. Okay, so tree, what is the property of tree? It should contain all the nodes present in the node. So how many nodes are there? 1 2 3 4. But what is the second condition to form the tree? No closed path should exist. So this is one tree. So you can see the solid lines is there, isn't it? So the solid line is a tree formation. So I have considered branches. Just give me 1 minute. Yeah, so branches A, B and D are connecting all the four nodes, isn't it? So first condition of tree formation, let me take you back to the formation of tree. See, among the properties, what is the second property? We can see that it should contain all nodes of the original graph. So among these five properties, second property and third property are very important. We'll only check these two properties. We are not concerned about remaining properties, because the remaining properties will automatically be satisfied if these two conditions or properties are satisfied. So first condition is should contain all nodes. Second condition, there should not be any closed path. So coming back to our example. Okay, so this is one tree. So check whether all those two conditions are satisfied. So the tree is nothing but the blue line that I have indicated is the tree. So it is connecting all four branches and we are not finding any closed path here. Okay, here also this is one more example for tree formation. So you can see one branches B, C and E I have considered as tree. So first condition is satisfied. It is connecting all the four nodes. So there are no closed loop. Okay. So here the branches A, D we are removing in order to form the tree, isn't it? So A, D branches are called links and B, C, E are called twigs. See, remember that every graph will have many number of trees. There is no unique tree formation for a graph. Okay, there are many number of trees can be formed for a original graph. Okay, so these are all the possible trees. So you can see in the last two examples also, it is containing all the 4 nodes and there are no closed path. So I hope you have understood what is tree, what is link, and what is twig by this example. Uh, One more example. Here also, he has given 4 nodes and how 5 branches are 1, 2, 3. Okay. Oh yes, forgotten. I forgot. So let us consider this as F. Okay. Okay. So this is one tree. A, B, D I have considered as tree. You can see that it is connecting all the 4 nodes and we have no closed path. Okay, this is one more. These are all possible trees. You can check whether all the conditions are satisfied. So in this also it is connecting all the 3 nodes, no closed path. In next example, the blue line indicates the tree. You can check this condition in all the examples. So in all the examples it is containing all the 4 nodes and no closed path exists. So for every graph there are many possible trees. Okay, so while doing some one student can consider one tree and another student can consider another tree. Okay, that is not in our hands. So depending upon your choice, your answer will differ, but we'll evaluate according to the tree you have chosen. Okay, but everyone will not get the same answer because there is no unique tree for a given graph. So all these are possible trees for the given graph. So the branches that we are removing to form a tree, we call it as links, and every branch of a tree we call it as twigs. Okay. Before I go to incidence matrix, I hope it is clear what is twig, what is link, and what is tree. So mainly this incident matrix. So matrix, every row of this matrix will correspond node of the original graph, and every column of the matrix represents branch of the graph. So the order of this matrix is n cross b, where n is number of nodes and b is number of branches. Okay. So what is the procedure to construct this incident matrix? The first step is we need to draw graph of the given network and indicate the number of nodes and branches. The second step, we have to assume some arbitrary direction of every graph. So we should make the graph oriented by assigning some particular direction. The third procedure, we should construct the incident matrix by writing horizontal elements and vertical elements. So just now we have seen, isn't it, what are horizontal and what. So according to this, we need to enter the matrix. So matrix entries will be either +1, -1 or 0. So these three will be the entries of the matrix. So when will I have +1, when will I have -1, and when will I have I0? So if there is no connection between branch and node, then we'll consider that as 0. If the branch direction is away from the node, it is +1. If the branch direction is towards the node, it is -1. Okay, we'll understand by means of an example. Okay, let me consider this as an example. Okay. As I told you, how many nodes are there here? 1, 2 and 3. So 3 nodes are there. 1, 2, 3. So column wise, so I have seen the rows of the matrix is number of nodes and the columns of the matrix is number of branches. So A, B, C, D are the branches, isn't it? So first I will consider first node. When I consider first node, what is the relation between first node and branch A? Branch A is going away from first node, so it is +1. Branch B, is nowhere in relation with first node, then it is 0. C branch, it is coming towards the node, so minus 1. D branch also is coming towards the node, minus 1. Let me consider second node. A branch towards second node, minus 1. B is also towards, minus 1. C is nowhere, C and D branches are nowhere related to second node, so 0, 0. Considering third node. A branch is nowhere related, 0. B branch is away from third node, plus 1. C and D are also away from third node, plus 1 and plus 1. So this is how we construct incident matrix. Any doubts? Am I clear in this example?
Yes, sir.
Okay. So after constructing incident matrix, you can check whether your answer is correct or not. Only in this matrix I can check. How can I check? Okay. This is the condition. Let me go back to this slide. Okay. When this you need, the first condition you need to, you can cross check. Addition of each column of the matrix should be 0. This condition must and should be satisfied for incident matrix. So if I add all the entries column wise of the incident matrix, it should result me to 0 value. So in this example, let me cross check this whether the condition is satisfied. First column, when I add those, it is becoming 0. Second column, it is 0. Third column also is 0. Fourth column is also 0. So every column, when I consider an incident matrix, when I add all the entries, it should and must become 0. That is how you can cross check whether your answer is correct or not. Okay. So the second example, this was once asked in previous semester paper. Okay. He has given this circuit and asked us to construct incident matrix. How many nodes are there? This is a node. This is also a node. This is also a node. Then this is one node. So all this, the reference is all one and the same. Okay. So when I consider a circuit, then I can consider 3 branches as one node. But if he gives directly the graph, then we should consider as it is according to what example he has considered. So here you can see how many nodes I got: 1, 2, 3 and 4. So similarly I consider that here 1, 2, 3, 4. So every line segment I have replaced by one line segment. Here I have voltage source replacing by short. Here also I have voltage source, I am replacing by short. Okay, so this entire thing is one branch. Okay, let me, for my convenience, for your convenience, let me change the color. So this is one branch, this entirely one branch. So that is what that I indicated as A branch. Capacitor one branch. Okay, see here I have current source. I told you earlier, if I have any current source, I should replace that by open circuit. So when I replace by open circuit, I will only have inductor. That I have replaced by short, one line segment. So this is the graph that I obtained by replacing everything. So here also this current source I replaced by open circuit. So now this graph, how many nodes are there? 4 nodes are there. How many branches are there? 6 branches are there. So entries we can, so since you know the concept, first node A branch is towards, plus minus 1 since it is towards. B is away, plus 1. C away, plus 1. D, E and F is nowhere related to first node, so 0. Second node, A, B are nowhere related, 0. C is towards, minus 1. D is away, plus 1. E is away, plus 1. F branch is nowhere related to second node. So third node, when I consider, the A branch is and B branch as well as C branches are nowhere related to the third node, so it is 0. D branch is towards the node, so it is minus 1. E branch is also nowhere related to third node, so it's 0. And F branch is away from third node, it is plus 1. So the fourth node, A branch is away from fourth node, plus 1. B is towards the fourth node, minus 1. C is nowhere related, 0. D also is nowhere related, 0. E is towards the fourth node, minus 1. And F is also towards the node, that is minus 1. So this is how your incident matrix is formed for the given example. So let us consider the third example. Here also the number of nodes I have is 4 and the number of branches I have is 5. So first node, when I consider, A branch is away, plus 1, B no relation, 0, C is away, so plus 1, D is also away, plus 1, E is nowhere related, 0. So second node, A is towards the node, so minus 1, B away from the node, plus 1, C nowhere relation, D, E also is nowhere in related to second node, so all are zeros. So when I consider third node, so A is nowhere related, so 0. B is towards the third node, minus 1. C is also towards the node, it is minus 1. And D is nowhere related to third node, so 0. E is away from third node, so it is plus 1. And last node, fourth node, when I consider, branches A, B, C are nowhere related, so all are zeros. So D branch is towards the node, so it is minus 1. And E also is towards the fourth node, so it is minus 1. So this is the incident matrix for this third example. The fourth and last example, we will understand and construct incident matrix. So here how many nodes I'll have? 1, 2, 3 nodes, and this is reference, so 4 nodes in total. So first we have to form a graph. So we know how to form a graph for a given circuit. Since I have a voltage source here, so I am replacing this by short circuit, and all other elements I am replacing just by one single line segment. So I can assume my own directions. So in exam everyone may not get the same answer because one may differ in assuming the arbitrary directions of every branch. So here the number of nodes are 4, the branches are 6. So when I consider the first node, the A branch is away from first node, so plus 1. B is nowhere related, 0. C is towards the first node, minus 1. D, E are nowhere in relation with first node, so 0. And F is away from the first node, so it is plus 1. This is the second node. When I consider, A branch is towards the second node, so it is minus 1. B is away from second node, plus 1. C is nowhere related, 0. D is away, plus 1. E is nowhere related to second node, 0. F is also nowhere related to second node, it is 0. So the third node, A branch is nowhere in relation with third node, so 0. B is towards the third node, minus 1. C and D branches are nowhere related to third node, so 0. E is away from third node, plus 1. F is towards the third node, so minus 1. And last node, that is fourth node, A, B branches are nowhere relation, so 0. C branch is away from fourth node, so it is plus 1. D is towards the fourth node, so minus 1. E is also towards the node, so minus 1. F branch is nowhere related to fourth node, so it is 0. So this is how we form incident matrix for the given circuit. So this concludes my today's lecture on the first part of network topology. So we have discussed some basic terminologies we have understood by means of some examples, and we have also seen how to construct the incident matrix for a given circuit. Okay. So in next class we are going to discuss how to form a Tyson matrix. Thank you.